Okay, so if we want to solve this by substitution, usually we want one of these to be like y equals or x equals something something. So we want one of the variables isolated first. And so I can see that for this top one, I can easily isolate the y by just adding 2x to both sides, kind of sending the 2x over to the other side so that I'll have y equals, I can either say 3 plus 2x or 2x plus 3, doesn't matter. But so you add 2x to both sides, so you'll get a nice positive 2x, and then the 3 stays positive. Now that you have the y isolated, you can substitute that y in for that guy. So I'll just say that this is 3x minus 2, and then instead of saying y, I'm going to say what y equals, 2x plus 3, and that should be equal to 5. And then this just has one variable, so this is really nice to solve. Collecting like terms, adding the 6, and then dividing by -1. And then so that's the x, and then I can get the y just by plugging it back in to that nice equation that I have y solved for. So y equals 2 times -11 plus 3. So -22 plus 3 is -19. So my answer is x is -11, y is -19. And let's check that. So we can put that in to these original guys here, and let's hope. So hopefully -19 minus 2 times -11, hopefully that equals 3. So that's -19 plus 22. Yeah, that equals 3. So it works in the first guy. Has to work in the second guy too, so we'll do 3 times -11 minus 2 times -19. Hopefully that equals 5. So that's -33 plus 38. Yeah, that equals 5. So it works in both. And we did it. Okie dokie. So we want one of these to be either x equals or y equals. And this guy is a nice target. He's all alone, and he's going to be easy to strip away from the other things. So I'm going to go ahead and try to solve for that x. I'm going to subtract 2y from both sides. So I'll just have 2 minus 2y equaling a -x. And then I'll have to divide everybody by a -1 in order to get a positive x, which I want. And then, so I'll have -2 plus 2y equals x. So now I'll take that and I'll stuff it into the other one. So I'll have 23 equals 5y times 4 minus 4 times -2 plus 2y. I should have said substituted into the other one. That's the name of the game. So we have 23 equals 5y plus 8 minus 8y. So 23 equals -3y plus 8. And then I will subtract 8 from both sides to get 15 and divide both sides by -3. So I get y equals -5. Found one. So now I'll go and plug that in to figure out what my x is. So -2 plus 2 times -5 will be x. So -2 minus 10 is x. So -12 is x. So my final answer is the x is -12, the y is -5. Sometimes they write that in a little x-y ordered pair. You could check it. I already checked it before I did this, and it will work. If you put it back into both equations, it'll make them true. So yay. Okay, so again, we want to get either x alone or y alone first. I notice this guy is an easy target. He's just all alone and lonely. He has no coefficient. He's going to be easy to isolate. So if I just add 1 to both sides, swing this guy over here, I'm going to get that 2y plus 1 equals x. And then I'm going to substitute that in for the x in that guy. So I'll have 7 times 2y plus 1 minus 2y equals 1. So 14y plus 7 minus 2y equals 1. So 12y plus 7 equals 1. Subtract the 7, negative 6. So y is negative a half. It's fine. And then we'll go ahead and plug that back in to figure out what x is. So 2 times negative a half plus 1 is x. So 2 halves make a whole, and it's negative. So x should be 0. So that should be my answer. X is 0, y is negative a half. And if I put them back in, they should work. Let's go ahead and check it because I haven't checked this one. So if I put it into that one, I'd have 7 times 0 minus 2 times negative a half. Hopefully that equals 1. 0 plus 1 equals 1. We are happy. And then we'll plug it into this one. 2 times negative 1 half hopefully equals 0 minus 1. So negative 1 equals negative 1. Excellent. We are good. All right. So the directions for this one, just to say to find out if it has one solution, no solution, or infinitely many solutions. So I was kind of debating how I wanted to go solve, because I don't actually have to solve the whole thing in order to figure out which one it is. And so if the directions say to do this, you can just look at the slopes of the lines, because we know if we have no solution, they're going to be different lines, but they're going to have the same exact slope. They're going to be parallel lines. And we know if we have infinitely many solutions, they're going to be the same exact line. And then if they have different slopes at all, then they can't be parallel and they can't be the same line, so they're going to have to cross once. So that's one solution. So I can figure it all out just by solving y equals and comparing my lines. So I'm going to do that. I'm going to divide everybody here by a 6 to get the y alone. So I'm going to say that y equals negative 5, 6x plus 4. And then I'm going to get the y alone on the other guy. So if I subtract the 2.5x over, and then I divide everybody by 3, I can isolate my y. And negative 2.5 divided by 3, I can look it up, it's negative 1.2. And if I'm comparing the slopes, I mean, they're certainly not the same line, because this is, if you changed 1.2 into a fraction, that's 1 2/10, which is 1 1/5, which is 6/5. So it's negative 6/5, I lost my x, plus 4. So it's interesting, their slopes are almost the same, but not. Oh, wait a second, hold up, 2.5, I think I did it upside down, 2.5 divided by 3. Hold up. I messed it up. It's negative 2.5 divided by 3 plus 4. If you do that, you can either yank out a calculator, or you can do negative 2.5 divided by 3, which is negative 5 halves divided by 3, which is negative 5 halves times the reciprocal of 3, which is negative 5, 6. Oh my goodness, look at this. So it's negative 5, 6x, keep losing that x, plus 4. They are the exact same line, right? So if they are the exact same line, they will have infinitely many solutions. This system will. And that's because they overlap at every single point on the line. So that's, if you know it's going to, that's all they're asking for, then you can just do that. I opted not to do normal substitution or elimination because it's a little bit, it'll send us to fraction land trying to solve for one of those variables, but you could. If you were to just solve this kind of like we solved our other ones where we just tried to isolate the x and plug one into the other, if you ever got a no solution answer, that's when you get weirdness at the end. You get like 0 equals 5 and the variables dropped out and you're like, no, no it doesn't. And if you got the same line, the variables drop out, but you get something that's very true. And if you get one solution, this is normal where the variables don't drop out and you get x equals something and y equals something. So if you were to solve these and you just didn't know that something weird was going to happen, you're looking for one of those cases. So no solution would be if you got something false at the end. Infinitely many solutions would be if you got something true at the end. And one solution is just your normal. The x's don't go away and you just get x equals something. So maybe I'll do the next one that way and we can see it. But I do like also comparing the slopes and just comparing the lines. So if they're the same exact line, infinitely many. If they're same slopes but just parallel lines, no solution. And if they're different slopes, then they have to have one solution. Sorry, my notes are messy, but hopefully you're writing this and making your own beautiful notes. Okay. Okay, so this one I'll solve both ways. I'll solve it the way we just, because still the directions are just one solution, no solution, or infinitely many solutions. That's all it's asking. If it had one solution, it's not even asking us to find it, so whatever. So if this is all it's asking, you can just compare the slopes by getting y equals, putting it into that form and comparing them. So if I try to solve for y in this first one, I'm going to subtract the 1/2 x over, and then I'm going to divide both sides by 3, and I'll get 5/3 minus 1/6 x equals y, and that's that guy. Leave him be for a second. And then if I solve for y in this one, I'm going to divide both sides by 6, and I'm going to get that's 5/3 minus 1/6 x equals y. Huh. So it looks like they are the same line again. And in that case, they have infinitely many solutions. Ta-da! And that's all they wanted to know. If if the directions didn't start here, if they just handed you this and said, yeah, go solve, and you didn't know anything potentially strange would be coming, let's solve it that way like we were doing for the first problem. So I'm going to restart, just rewrite the original problems. And this one's not too bad to solve. I'm solving by substitution, so I want to get either the x alone or the y alone. It's pretty easy to isolate my x in that case. So I'm going to go ahead and subtract 10 from both sides, and that'll get me negative x equals 6y minus 10. But then I have to divide everybody by a negative 1 because I don't want to know what negative x is. I want to know what positive x is. Well, that's negative 6y plus 10. So I got that. And then I want to substitute that into the other one. So we get 5 equals 1/2 times negative 6y plus 10 plus 3y. And then I'll distribute. So half of negative 6 is negative 3, half of 10 is 5. And when I go to combine like terms on this side, negative 3y plus 3y goes away. So then I'm looking at 5 equals 5. And this is, so the variables dropped out, right? Variables dropped out. So something weird is happening. It's either no solution or all real numbers. Very different. Variables drop out. And we're looking at this, and it is strange, but true. 5 always equals 5. So this is infinitely many solutions. And that's exactly what we said it was going to be up here. So yeah, so if you get something weird where the variables drop out, you either get something that's strange but true, infinitely many solutions, or you get something that's strange because the variables dropped out but false, and that would have been no solution if that had happened. All right, hope that makes sense.